So speaking of great events, we now have a fantastic speaker, and I'm very much looking forward to this next presentation. So we have Alex Glow, who you also may know as Merlin, will be talking about one of her latest open hardware projects. So welcome, Alex.
Thanks, Becky, you rock. Becky super rocks. I took her workshop yesterday. It was amazing. Hey, so I'm Alex. I work at this company called Hackster.io, which is a place to share tutorials. And so this whole thing that I'm going to show you is a tutorial on how you can use these kits that I have that are for you. They are free. Just come grab one at some point. And I'll tell you about what's inside of it in just a minute. There's also a bunch of cool stickers and batteries and stuff. And Jeremy at the back is taking apart the batteries so that everyone can have one, which is so nice of you. All right. Can everyone hear me? Fabulous. Okay, so what is Charmware? Charmware is, as you have figured out, a modular tech, jewelry, or general accessories system. So the way that I think about circuit diagrams when I'm trying to figure out a circuit that I've found is I draw it in these flowing lines with the power flowing from one part of the circuit to another. To me, it doesn't make sense a lot to draw it out in right angles and stuff, because you never really know how the whole circuit is going to look. Same thing when I'm designing something, and so I wanted to build a system that lets me build electronics in the same way that I think about them and design them. And it's also a great way to get introduced to electronics if you've never done it before, and also to learn PCB design. So this is my first set of PCBs that I've ever created. So basically, it allows you to string together components, including, for example, you can see here button, surface mount LEDs and resistors, which I chose as a very large size, so you can solder them by hand. You can also use these little ones to connect haptic motors, through-hole resistors, reed switches, tilt switches, whatever. And then the larger one is a coin cell battery. So I started out with a larger coin cell battery shaped a CR2032, which is quite large, and I've since evolved that to be much smaller with a CR1220. So it's much more sort of jewelry friendly at this point. And if you come up, you can see that I'm wearing an example of this that I've put together, which the white wire leaves something to be desired, but you can see at least it's a functioning prototype. And this is basically the most minimal possible module. It's just a 3-volt battery and a surface mount blue LED, which blue LEDs take enough energy that they don't generally need a resistor in line with them, which is pretty awesome. So I wanted they originally were called PC beads because I wanted them to be basically like a kid-friendly approach to electronics, in the same way that bare conductive is basically finger painting for electronics, right? And crazy circuits is Lego for electronics. And you know, tiny circuit, or what are they called? Circuit stickers are just stickers for electronics, which, by the way, are totally compatible, as you can see on the right side of this image. Originally, I wanted to embed components in spherical beads of resin, but that turned out to be really impractical, and these are much easier to mass produce. So these are all named after space things so far. And you can see in the design here that it's really basic, because when I opened up Eagle for the first time, and I was trying to learn how to design my own PCBs, the example that they give you is an entire Arduino, which, if you've ever looked at the circuit diagram for an entire Arduino, it's extremely intimidating. Like, that's not going to be your first project. And so this is simply 2 planes. It could be a positive plane and a ground plane, or you know, any 2 planes that you want. A resistor is nonpolar, so it's just like 2 planes to connect to. And then in the center, you can plonk down a surface mount resistor or LED. Just choose which side is positive and which side is ground. You can mark on it with a gold marker or whatever. The ones next to the middle surface mount pads are for a through-hole resistor, and then the ones at top and bottom are for larger components. So it's super easy. You can basically plonk down any kind of a footprint that you want on here, as long as it's 2 things, and just angle it so that it goes across them, and then you're done. And you have your own custom thing, and you can contribute to this open source project, which I think is one of the most exciting parts of starting out as a maker. And then this one is a little more complex because it is a surface mount battery. That one you can tell that it's part of my efforts to learn PCB design because what I actually like about it is that there's these little planetoid lines on it, and they're not super regular, and they don't really make sense, but they look really naturalistic. And I really like how organic the whole system is. So what I have in these kits, since you're here, I will tell you, you have a large battery holder, and you have a smaller star module, which is the one that I told you about where you can attach all the things. And then down here, you'll also find a teeny tiny surface mount blue LED, which has a green line on one side for the ground side, and also a surface mount battery holder. Unfortunately, the battery holder is a little bit different from the footprint that I had to work with for the 1220 battery. And so there's a little bit of finagling that I'm putting up. I've recorded a video of how to make that work. And I'm going to put that on this tutorial as well. So you can find this at bit.ly/charmware. And if you're curious about the owl, he's at bit.ly/robotowl. We can talk about that in a second. Yeah, so as I mentioned, these aren't just for LEDs and batteries. With this minimal set, you can connect sensors, you can connect haptic motors, you can connect switches, like either regular buttons or magnetic switches or like tilt switches that detect motion or anything like that. And in the future, since everyone's asking me, is it an Arduino? It's going to be an Arduino. So the next few modules are going to be an attiny85, a 555 timer chip. So the attiny can be programmed with Arduino code. And I'm going to make a breakout for this. A 555 timer is really useful for doing like DIY music and sound projects, as well as like random like periodic clicks and things of all types. And there's also going to be a NeoPixel module and things like that. But for now, I'm just kind of firming up the design. Yeah, the process of designing this has definitely had its pitfalls, and I would love to share some of those with you. But first, some more example circuits. So the one that I'm wearing is the kit that you're going to get if you just come up and pick it up afterwards. And that's basically the battery and LED. I also have a little tester that's just like a battery plus two little probes. More demo circuits. Here's a battery plus a resistor plus an LED, and you can turn it into a bracelet or whatever. I want to show you another feature of this necklace as well, which is that it has a magnetic clasp at the back. And the cool thing about magnetic clasps is that they're made of metal, which means that you can, oh no, you can solder to them, and then you can lose them around your neck because you made your necklace way too long, and you decided to wrap it all the way around and be cute. There we go. Oh yeah, so there we go. You can see the LED like turning on and off. And that's just because it's a little magnetic clasp. It's super cool. And those you can get easily on Amazon and whatever. This is the minimal pair with a circuit sticker. It's a coin cell holder and just an LED circuit sticker. And then there's a haptic motor one. Unfortunately, it seems like we can't zoom in a camera or whatever, but you can come up and see these after the fact. And I'm excited to hear what you have to do with them as well. So more stuff about the PCB design, right? So Oshpark is a US-based PCB manufacturer. All of this stuff, as the name implies, is open source. So it's all open source projects people have uploaded. And they offer this half-height service where your PCB is half as thick as a regular one, which is really awesome for aesthetics a lot of the time, but it doesn't apparently work really well for jewelry because it makes it kind of sharp and bitey, which is not nice. Another thing is that you can order a lot of them and you get the PCB fully routed out. This is something you want to check if you're designing your own PCB. The earlier ones have these little rough bits on the sides called mouse bites, and that's because they were all assembled together in a panel, and then they get broken out of the panel one by one, kind of like old like army figures and whatever, right? And so as a result, they have these little sort of serrated edges, and you can get large numbers of PCBs fully routed out. So the new ones that you're going to get are like super smooth around the edges and are really nice. Another thing I learned is that I designed some diffuser modules. Let me show you. This is Osh Park, the place where you can order the PCBs. So you can order these yourself, actually. Where's the previous version? Oh, I haven't shared it. No, because it kind of sucked. So the thing with that is that turns out Eagle has a setting for whether or not your vias are coated with solder mask. And I made these two little diffuser modules with a bunch of little tiny via holes in them because I was like, oh, if you have an LED on a wearable, you probably want to diffuse it, right? Like have it shine through a bunch of little holes, it'd be nice. Yeah, it turns out all those little holes are going to be covered up if you don't set this one thing in Eagle, which is called tenting. So if you're designing a PCB where you want light to shine through it, you have a couple options actually. You can make a bare section of the PCB with no copper or solder mask, but you can also put little vias through it and just make sure that you set your tenting threshold low enough that it doesn't fill it with solder mask. Let's see. So I've got soldering and assembly demos on here. I'm going to be doing some at the hardware hacking area later on. Or you can hit me up on Twitter. I'm at Glowaski. It's spelled like this. But you can also follow me for updates about projects and things, a bunch of stuff about Charmware. So again, as I mentioned before, these were designed based on the way that I envision circuits. Come on, load. How keep from stabbing? I haven't figured that out yet. I think maybe hot glue is the answer, but I'd love to hear your ideas. And basically, this is the design. So one of the key features here is that you'll see these large holes on the edges. And those are because when you're soldering something that needs to move around with a body, you're going to get a lot of flex and strain on that solder joint. And the problem with that is that obviously it's going to break, especially if you're sort of like wearing it every day and stuff. You can stabilize it with hot glue, but that doesn't look very good. And so the other thing that I built in here is strain relief holes. You basically thread the wires through the big holes on the sides so that it pulls on sort of the wire itself with friction and not on the solder joint. I also want to hear what you all want to build with these, because I bet there's some much cooler ideas than I've got going on here. There's a little bit more about why they were designed the way they were and stuff, but yeah, as I mentioned, it is an open source project, so I want to hear what you would plan to make with this, and either I will make it or you will make it, and the world will be a better place. So check out bit.ly/charmware. And if you want to hear about the owl, go to bit.ly/robotowl and go find me on Twitter or Instagram. But what I want to do right now, since everyone's still in their seats, is have you come up and get a kit and ideally a battery from Jeremy on your way out. But for right now, let's do some questions if anyone wants to know anything.
So yes, we just ask if you wait for the microphone so everyone can hear your question before you ask it. So.
Oh, also I want to make like epaulets and stuff too, not just like jewelry.
I've never done PCB design, and cool. I'd really like to get into it. This seems like a cool project to contribute to. What are like good resources to get into PCB design? So I only understood like a few of the things you said about the process.
Yeah, so SparkFun has some really great tutorials in getting started with Eagle, which is one of the most popular choices. Probably it's between Eagle and KiCad, the most popular ones, and Upverter is becoming popular too. So Eagle, SparkFun has a great tutorial series. And for KiCad, my friend Chris Gamble, who does the Ampower podcast, yeah, he has a Getting to Blinky series for KiCad. And he actually recently revamped it so that it's more comprehensive and better and glowy in every way. There's also like a burgeoning PCB art movement, which is really exciting. People doing sweet badges and stuff. All kinds of stuff to explore there that we could chat about.
Hi, I was just wondering how compatible this would be with something like conductive thread or any kind of conductive material that can take strain.
Yeah, so the strain relief would probably help with that. The thing with conductive thread, so I think it's awesome that it exists and people use it. I personally hate working with it because it's not very flexi resistant, or it doesn't have a lot of flexi strength. And so I think that especially given that the sharp edges of the PCB, even in the little holes, it has a little bit of a sharp edge, it would probably wear through the conductive thread even faster. But what you could do actually is like use a bunch of regular thread to sew it down and then put the conductive thread with no strain on it. And that would probably help because then it wouldn't be like rubbing and moving around as much. I would love to see that.
Hi, Alex.
Hi, Cleo.
So, have you tried filing down the edges of the PCB?
You could totally do that. The main thing with this is that the PCB substrate, the middle part, the base, is made of fiberglass. It's called FR4, and as I know from snapping apart a bunch of these, it gets into your skin as little slivers, and it's not very pleasant. So I would not recommend filing it down, but you could try other methods. Like you could also coat it with hot glue or whatever. Hot glue is great as a stabilizer and to insulate things from each other. So if you're wearing a bunch of conductive stuff, like it doesn't look super great, but like you can put hot glue or heat shrink on it, probably help. Ooh, I wonder if you got like a really big diameter of heat shrink, if you could just like cut a thin slice of it and put it around the edge. That'd be pretty cool. What's conductive paint? Yeah. Totally. You would, again, have to seal that because bare conductive is water soluble, right? Yeah, totally. Adam suggested putting a glob of bare conductive paint over the conductive thread and then putting super glue on the outside to seal it.
Yeah. What's the best way of attaching electronics to clothing such that you can remove it when you want to wash the clothing?
I think maybe magnets. That's sort of my favorite, but you could also do Velcro, obviously. I just prefer, I think there's some kind of Velcros that are really low profile, but I think in general it looks kind of messy. But I'm really focused on aesthetics, so Velcro is like a totally viable solution. I just use, bike inner tubes and just like wrap it around. I'm a big fan of like harnesses and wrapping things, so honestly I usually go that way. But snaps are a big one, especially with conductive thread. People do like they sew onto the snaps, and you can use that as a switch as well as just an attachment mechanism.
And
I feel like I'm constrained here. Don't need the computer anymore. I'm free. Yeah, come and get boards. Yeah.
You mentioned aesthetics earlier, and you also mentioned resin.
Resin, yes.
These obviously really look like circuit boards currently. Mm-hmm. Was your thought there to make them literally look more like beads and more like jewelry?
Exactly, yeah. So the idea with the resin was to make them look, as you say, exactly like beads.
Yeah.
I loved the fact that they were like basically the same. It still wouldn't have the same mechanism. You would have to like figure out a way to solder into the sides of the beads.
Yeah.
I would still love to do that, and I think it would be really beautiful, especially the LEDs sort of embedded in like a cloudy resin. You'd get this beautiful sort of glowy effect that I love the idea. However, resin is such a sort of fidgety thing, and especially being able to sort of give out 80 kits at a talk, that would be really, really difficult for me, honestly. And there are ways of getting it manufactured and stuff too. If you would have any ideas, I would love to hear.
Well, I've only just started playing with resin, and it turned out to be more of a nightmare than I thought it was going to be.
I know, right?
So hot glue, yeah, I get it. It works great, but it doesn't look quite so good. But maybe hot glue in a mold as a kind of a finishing process. So you build the thing first, and then the mold clips around the things, and you just fill it full of hot glue.
Right.
Because it's almost you kind of don't want the awkwardness of the soldering. The soldering with the beads as they are is great and it's easy. If you could then kind of finish it by going bead, 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 bead.
That's a great idea.
And it holds the strain relief as well.
I never thought of that. Yeah, you do all the soldering first and then create the beads around it.
Yeah.
Plus, that solves the problem of not being able to solder without melting the hot glue. Oh, that's
Absolutely.
fantastic.
And then you end up with a chain of beads as a bracelet or a necklace or whatever.
Yeah, and that automatically reinforces it as well.
Yeah.
Oh, you should totally hit me up on Twitter or whatever, and
Cool, okay.
I would love to try that out and give you credit, or you try it out and I share it or whatever. This is the username. Yay, I'm so pleased. There's also a bunch of stickers there for Hackster and stuff.
Yeah, let's take salad.
Thank you. Not sure where we are on time. What time is it? 1:32. Oh, perfect. Got like 8 minutes or something. Yeah, cool. So yeah, come grab kits, come grab stickers, and come chat with me if you want to see more of the little demos and stuff. Yeah. Thank you. Thank you, Becky. Thank you, everyone. Thank you, Jeremy. Yay.